Hi, my name is Mohammad Abdulaziz. I have selected this topic Qantas Airways in MLI 503 assignment 3. In the next slide, I'm gonna speak about the introduction of Qantas Airways. Australia's flagship carrier, founded in 1920, is globally recognized not only for its service and innovations, but especially for its long-standing record of safety. With over a century of aviation excellence, Qantas has become a symbol of reliability and leadership in both domestic and international air travel. However, like many global airlines, Qantas faced severe operational disruptions during the COVID-19 pandemic. In the wake of these crises, the airlines has been strategically investing in modernization and innovation to not only recover but become a more resilient and future-ready. One such proposed innovation is the implementation of the AI-powered predictive maintenance system. This project aims to leverage the power of advanced analytics and machine learning and IoT technology to transform how Qantas approach aircraft maintenance, with the goal of minimizing unplanned downtimes, improving efficiency, and enhanced customer service. In the next slide, I'm going to speak about problem statement. In problem statement, despite the Qantas reputations for safety and service, its current aircraft maintenance process suffer from a critical limitation: the lack of real-time data and integrations. Presently, Qantas relies on schedule of reactive maintenance strategies, which often lead to inefficiencies such as unexpected flight delays, highly maintenance cost, and customer dissatisfaction. These reactive models are unable to prevent unplanned downtimes, which disrupt operations and impact the airline's bottom lines. According to Schofield, the airline currently maintenance strategy lack predictive insight, making it difficult to anticipate and prevent potential component failure. This result is avoidable disruptions that ripple across the network, affecting the scheduling, staffing, and passenger experience. Clearly, Qantas need a smarter, more proactive system that harness the power of data to drive timely and effective maintenance decisions. In the next slide, I'm gonna propose the analytical improvement. In this, to address these operations inefficiency, we propose the integration of the AI-driven predictive maintenance systems that utilize the Internet of the Things like IoT and devices and machines learning algorithm. These this innovative solution will enable real-time data collection and predictive analytics to forecast the failure of aircraft components well in advance. Drawing on the work of the Khabashkin and the Shoshin in 2024, the system will analyze sensor data from various aircraft systems such as engine, fuel systems, and avionics to predict the fault before they occur. These early warnings allow engineers to schedule maintenance during the non-peak time, dramatically reducing the risk of the flight incident or ground delays. This aligns perfect with the Qantas commitment to digital transformations and operational excellence. Ultimately, the proposed system will help Qantas become more efficient, agile, and competitive in a rapid evolving aviation landscaping. In the next slide, I'm gonna speak about technological overview. The core technological behind the predictive maintenance involve the use of AI algorithm that can process and analyze vast amount of real-time data from aircraft system. Thousands of sensors embedded in the aircraft continuously monitor parameters like engine temperature, fuel pressure, vibration level, and hydraulic systems. These data points are transmitted to a centralized cloud-based platform that enables scalable storage and real-time analytics. Through continuous learning loops, machine learning models become increasingly accurate in identifying potential failure. Like the system not only detect earlier sign of malfunctions, but also recommends maintenance action and timelessness. This result is a significant improvement in the aircraft reliability and the safety while optimize the allocation of the maintenance resources. With cloud computing and edge processing capabilities, data analyzing is swift and efficient, supporting quick decision making across engineering teams. In the next slide, I'm going to give technological cost analysis. The implementation of the AI-based predictive maintenance systems does involve a significant initial investment. The total estimated cost is projected between 30 to 50 million dollar over a 2-year period. These costs encompass systems, integrations, training program for engineering and IT staff, procurement of the IoT hardware, and the establishment of cloud infrastructure. Additional recurring expenses include software license, data storage, and the system updates. However, government grant and innovation-focused subsidies may help offset some of the initial financial burden. While the upfront cost may seem substantial, the long-term economic benefits far outweigh the investment by avoiding costly unscheduled and repairs, reducing the flight delays, and enhancing the fleet utilization. Qantas is expected to recover these costs and achieve the robust return on investment within a 5 year. In the next slide, I'm going to tell you the benefit analysis. In benefit analysis, implementing predictive maintenance is anticipated to bring a range of operational and financial benefit to Qantas. The most immediate impact will be reduction of the unscheduled maintenance events by up to 30% annually, leading to improved aircraft availability and fewer flight cancellation or delays. These improvements directly enhance the passenger experience and increase the customer loyalty. In financially, the initiative is expected to generate cost saving exceeding $100 million over 5 years through optimizing maintenance scheduling, improved asset utilization, and decreased reliance on emergency repairs. Furthermore, predictive maintenance supports safety compliance by enabling time inspection and addressing issues before they escalate. It also boosts the airline's reputations as a customer focused, like technology advanced company commitment to quality and operation excellence. The next slide is about organizational impact. In this, transitioning to a predictive maintenance model will require significant organization change, particularly in workforce skills and internal culture. Engineers and IT personnel will need to be reskilled in the use of new technology, data analytics platform, and AI tools. The shift from manually inspection to AI-driven monitoring will necessitate a culture of data literacy and cross-functional collaborations. Like maintenance and IT department must work closely to ensure smooth implementation and operation of the new system. This culture transform will foster innovations and more proactive approach to maintenance management. Importantly, it aligned with the Qantas strategic ambitions to lead the innovations among Asia Pacific airlines, setting new benchmark for how airlines operate in the digital era. In the next slide, I'm going to tell you two things: feasibility and practicality. In Qantas is well positioned to adopt predictive maintenance technology due to its ongoing investment in digital transformation. With a model fleet equipped with advanced avionics and existing IT infrastructure capability of supporting real-time analytics. The feasibility of the project is high. Similar technologies are already being implemented successfully by industry leaders such as Boeing, Airbus, and the General Electric. Serving as a benchmark for Qantas, the proposed system is also scalable, allow for the phased rollout that begins with a limited pilot and expand based on success. The availability of the skilled technical staff and established vendor partnership further increase the practicality and the chance of the success of initiative. In the next slide, I'm gonna implementation the plan like phase one implementation plan. The first phase of the implementation will focus on 6 months pilot involving 10 aircraft from various fleets. This controlled rollout will allow Qantas to evaluate the system's performance in difficult aircraft environment. Key activities include selective technology vendor for IoT hardware, setting up the cloud data platform, and training maintenance teams on a new processes and workflow. During this pilot phase, feedback will be collected and used to fine-tune an AI models. Success criteria such as prediction accuracy, maintenance efficiency, and operational cost saving will be closely monitored to determine the readiness of the broader deployment. In the phase 2 implementation the plan, the following the pilot, the second phase will involve scaling the implementation to 50% of the fleet. This phase includes the extensive employee training and the recruitment of the data scientists and AI specialists to support data analysis and system operations. A communication strategy will also be launched to keep all stakeholders informed of changes and to ensure transparency. Additionally, the new system will be integrated with the existing enterprise resource planning like ERP tools such as SAP as well as the aviation specific systems. The expanded deployment will proceed based on the success of the pilot with adjustment made to address many operational challenges identified in the earlier phase. In the next phase 3 implementation of the phase 3, the final phase of the project spanning 18 to 24 months from initiation will involve full fleet implementation, a centralized operations hub for predictive maintenance will be established in Sydney to coordinate the system monitoring, data analysis, and the maintaining the scheduling. This hub will be responsible for the conducting regular performance review, updating machine learning models, and measuring ROI. In addition to aircraft maintenance, the predictive model will be extended to cover other operations areas such as baggage handling and the ground services. These broader applications of the AI will further enhance the operation efficiency and passenger experience across the travel journey. In the next slide, I'm gonna tell you the risk management. It's a main source of the topic, and several risks have been identified and mitigation strategies developed. Resistance to change among the staff will be addressed through, through earlier training and involvement in decision making. Data privacy and cybersecurity risk are mitigated by using ISO certified data protection protocols. The risk of vendor lock is reduced by choosing open architecture systems that follow for flexibility and integrations with other tools. Financial risk is managed through phased investment strategy that align with the measurable ROI milestones with a proactive risk management approach. Qantas can ensure a smooth and secure transition to predictive maintenance. In the next slide, I'm going to tell you about sustainability and CSR implication. One of the critical benefits of the predictive maintenance is its positive impact on sustainability by optimizing engine performance and minimizing fuel wastage. The system contributes directly to Qantas' net zero emissions target. Qantas Newsroom in 2022, the more efficient the aircraft operations result in the lower carbon emissions and reduce environmental impact. Furthermore, predictive maintenance reduces the need for excess part inventory and unnecessary maintenance checks, conserving resources and promoting responsible consumption. By adopting this technology, Qantas reinforces its brand image as an environmentally conscious and socially responsible airlines. In the next slide, I'm gonna speak about the advantages. The adoption of predictive maintenance provide the Qantas with a distinct competitive edge, especially over key rivals like Virgin Australia. The system enhances flight reliability, which is a crucial differentiator in the aviation industry. Customers are more likely to choose airlines that have fewer delays and cancellation, and this system allows Qantas to deliver on the promise. Additionally, the move of strengthens Qantas' position as a technology-forward brand that prioritizes safety, reliability, and the customer experiences. It is not just a technical improvement, it is a strategic business advantage that enhances the brand loyalty and market share. In the next slide, I'm gonna share some data governance and ethics. Qantas has committed to handling the data with the highest standard of the governance and ethical responsibility. The predictive maintenance system will comply with the Australian Privacy ACT of 1988 and aviation specific data regulations. The Qantas Clear Data Usage policies will implemented to ensure that AI models are trained and usually ethically. Periodic audits and review will verify compliance with the safety and privacy norms. Importantly, Qantas will maintain transparency in the algorithmic decisions making to build trust with employees, regulators, and customers alike. Ethical governance of data will be cornerstone of their project. In the next slide, I'm going to speak some success metrics. In success metrics, the success of the initiative will be measured by using the range of performance indicators. Key metrics include the reduction in the unscheduled maintenance events, improved on-time departures rates, and increased aircraft utilization. Employee satisfaction with the new system will also be evaluated through surveys and performance review. Financial ROI will be assessed quarterly, tracking cost saving and productive improvements. These metrics will not only to demonstrate the effectiveness of the system but will also inform continuous improvement efforts. And in the next slide, I'm gonna share some future applications. In that, looking beyond the maintenance, the predictive analytics platform of opportunity for expansion. It can be adapted to optimize fuel consumption, flight routes, and crew scheduling. AI-driven tools can also enhance the customer service, such as real-time baggage tracking, personalized travel offers, and faster check-in process. In Qantas could even establish a dedicated innovation center, Qantas Labs, to become a global leader in aviation's AI and data science. Strategic partnership with the tech firms will further accelerate innovation and open new revenue system. In conclusion, I'm gonna say that predictive maintenance represent as a pivotal steps in a Qantas journey towards and become the not only the safest but also the smartest airlines with a clear implementations roadmaps, a solid business case, and a strong commitment to innovations. Qantas is well positioned to lead the aviation industry into the future. This project aligns with the company's strategic objective, enhance operational efficiency, and delivers significant value to stakeholders. By embracing AI and predictive analytics, Qantas set a new standard for excellence in aviation, proving once again why it remains a global icon of safest innovation and services. Thank you.